outside this area. I'm actually in the Catchments unit in Agri-Environment branch, so most of my research is focused on the impact of agriculture on water quality and how we try and mitigate that. So I'm a bit of a blow into this. What I want to do today is give you an overview of the soil catchment programmes, which have been running now since the end of 2017, and it's work that's combined. It's funded by DERA to start with the EU Exceptional Adjustment Aid Scheme, then subsequently since by DERA, and it's involving CAFRI, who've developed all the education materials and delivered training to farmers. UFU have promoted it, and Ulster University have been involved in the research along with ourselves. So there's an awful lot of data, and I'm just going to give you a sort of overview of the findings at this stage. So there were 4 pilot schemes in total so far. It came out of the Sustainable Agri-Land Management Strategy report, which said that fewer than 10% of farms in Northern Ireland regularly tested their soil. So there was a drive, because that means that if you don't understand the soil nutrients, and I know in this group you all are the exception, you need to know your soil nutrient content to improve farm profitability, but also to try and understand what effect agriculture has on the environment, and maybe try and look at ways of mitigating that, getting rid of blanket measures and maybe something more targeted. So what we did, the open scheme ran first, and there were 522 farms across NI involved. They were allocated at random because it was way oversubscribed at 3,000 farms. At the same time as that, we ran a catchment-based programme in the upper band. We're on 11 sub-catchments and 2 that we work on ourselves. We recruited as many farmers as possible to have their soil sampled, so we could get a picture within river catchments of what the soil status was, and then compare that to water quality. And since that scheme ended, we've extended out into parts of the lower Struil around Ohm and the western and southwestern part of the Colebrook and Tempo catchments. So overall there have been 1,600 farms tested. There's 29,700 fields that we now have full soil test results going back to farmers, and CAFRI have trained almost 800 farmers in soil analysis and nutrient management planning. So every farmer that participated got the normal return in the post from NRM, which gives a tabulated outline of your fields and the P, magnesium and potassium status and pH, and what you need to do to fix it. For the catchment schemes, we added to that by doing a mapped-based approach, where every farmer received a map of their nutrient status and lime to start with, so pH, P and K, and they were colour-coded. And on top of the colour codes for each field was the amount of lime you needed to add, the amount of P you needed to add or not add, and the amount of K. And red are fields that are oversupplied, green are fields that are at the optimum, and yellow are ones where you need to do something. And training to support that was provided by CAFRI. The other thing we did for the first time in Northern Ireland, and anywhere else as far as we can see, is we looked at runoff risk. And so in Ireland and Northern Ireland, the landscape, the steep slopes, the clay impermeable soil and the heavy rainfall mean that overland flow pathways are the main route for nutrients and sediment to be lost from the land where it's useful, and into the rivers and lakes where it's less useful and more of a problem. So we took LiDAR elevation data and information from the AFBI soil survey on permeabilities, combined those, and for all farmed areas modelled where runoff would be highest during rainfall events. So where it's yellow and red on that map on the right is where most flow accumulates when there's a storm event. And these are areas then where there's delivery into the stream network, and places that we want to maybe target mitigation measures later on. In terms of the deliverable to farmers, they got a map like this with 2 main colours, yellow and red. The yellow are areas of fields where if you put on slurry, fertiliser or manure, there's a risk in these areas during heavy rainfall of runoff, because they're where flow accumulates. The red areas are where there's also a high soil P above the agronomic optimum. So where it's above the agronomic optimum, it's not being used by the plants, so it's available. And in these areas there's an additional risk of erosion and mobilisation of P like that. We also provided delivery points marked on the map that showed the main points at which overland nutrient flow would be delivered into water bodies. There are an awful lot of data, and we're only really starting to look at it in any detail. We've general summaries available. This is one of Alex Higgins's overview maps for phosphorus for for NI. Anything that's orange or red is in general above the agronomic optimum, so it's coincident with areas of the most intensive agriculture, but not exclusively. In some of the severely disadvantaged areas, up to 40% of fields were above the agronomic optimum for phosphorus. NI-wide, it was 43% above optimum and 23 below had a deficiency. When we look then as well at the catchments individually, Upper Bann was fairly similar to the NI-wide overall. But Colebrook and Struhl were different. In Struhl in particular, because it was focused around Oma, where it's quite intensive farming, 50% of the fields sampled were above the agronomic optimum and only 24 were at optimum. And Colebrook was slightly lower, but a lot more of that catchment is extensive land. So for potassium as well, there were differences, both NI-wide and compared to the focused catchment scales. Overall, 25% of fields are deficient in potassium. Out of the 500 in the NI-wide study, 47 are at optimum. When you go into the catchments in detail though, a much higher percentage were below optimum in Upper Bann, and that can, as you know, impact grass production. But when you move into Colebrook and Struhl, 55 and 72% of the fields tested were deficient for potash. That in part is due to the higher rainfall rates and how mobile potassium is in the soil. If water hits it, it'll run out. So there are geographic differences in how nutrients are being retained in soil that maybe need to be considered in advice on when and where to put nutrients. The other big finding is the amount of lime that's required. I suppose since the 70s and 80s there's been a steady decline in NI and GB in general on the amount of lime applications, and that's reflected in what we're now seeing when we look at the bulk data. 57% of the fields tested NI-wide required lime, and that's for pH 6 on mineral grassland soils and pH 5.3 on peaty soils. When you move to the west towards Colebrook and Struhl, 80 and 82% of fields were below the requirement and needed lime. And that again is probably to do with the higher rainfall leaching the soils. John Bailey's done a few calculations on this to work out how much lime we'd need and how much it would cost and what we might gain. For 43% of the NI fields that are good pasture, he's estimated that you need 1.2 million tonnes to make up the deficit that's there at the moment, and that would cost about £30 million based on £25 a tonne for lime spread. The average increase in grass that you get out of that would be 1 tonne of dry matter per year for 5 years, which he estimates would give you 1.7 million tonnes of dry matter, and the worth of that is £170 million. So for the £30 million investment to correct the lime issue, you could have a 5-fold return on that, is what we estimate, if this was corrected across NI. That's something that's being considered. There's sort of on the local scale, there are a lot of interesting things that you see when you look at the data, but the one thing that we've now been able to confirm is that there is a disproportionate spread of nutrients on farms, that the closer you are to the yard, the higher the soil P is in those fields. And as you move away, it goes back down and into sort of what might be the agronomic optimum. So there is a built-in tendency to spread nutrients on the fields closest to the house, and that's because it's handy, but it's also, I suppose, and because those fields, if your farmyard's on top of a hill, those fields are maybe better drained and easily accessible earlier in the year compared to the ones that are out and along the river further out. So, but at least we've measured this now. Another thing we saw, which was strange, is raths and ringforts that we sampled. They have very high P concentrations, and they stood out on all the maps that we looked at. So we're looking at the possibly very old legacy soil phosphorus there from thousands of years of habitation. So there's an archaeological bit that we could look at and we could try and date it, but it could also be that cows just like to stand around inside ring forts because it's a good view and sheltered. I suppose the bit that I've been most involved in looking at the data is how the catchment-based studies link to water quality. So we talk a lot about how high soil P is affecting the concentrations in rivers, but we've never actually had any data to prove it or really look at the relationships, and then once we know that, we can try and do something about it. So the main issue for failures of the water framework in Northern Ireland are oversupply of phosphorus into the streams, and that promotes grass growth on the land, but it causes algal blooms in streams and shuts during drier weather and lower flows, and that has an impact the whole way down through the ecosystem, so it affects the river health. And soils which are above the agronomic optimum have that surplus that can be lost, and that's what we've tried to look at as part of this. So what we wanted to know first of all was, is there a relationship between the proportion of a catchment that's above the agronomic optimum and the water quality in the rivers? And then what proportion of a catchment could be above the agronomic optimum without having an effect? What's the sort of carrying capacity? What's the slack before you start to see an impact? So for a catchment like this, which is a bad example on the right, it's one of our most intensively farmed catchments in Upper Bann. 60% of that area is above the agronomic optimum. And when we take the percentage of each catchment above the agronomic optimum on the x-axis and compare it with the river P concentrations, we've got a strong linear relationship to that. And from that linear relationship, it indicates that once you go above 15% of a catchment above the optimum soil test P, you're going into poorer water quality quite quickly. And that should be a sort of target when we're developing management at a catchment level. It doesn't mean that some farmers can't have a big surplus, but then there have to be others that balance that out. So that was the first rule that came out of this and applied to the Upper Bann and also to some of the Coldbrook catchments. The second thing we looked at was how much the high risk areas, so these yellow bits in the fields on the bottom picture, how much they affect and can impact water quality. So we looked at the proportion of catchments that are high soil P and also high risk. And we found coming out of that really you can't have more than 1.5% of the catchment area occupied by high risk and high soil P before you start to see a water quality impact. So really all these areas where runoff's delivered to streams need to be targeted and mitigated in some form. And these can be very localised measures, and they're an alternative to some sort of blanket ban on spreading. And good fields that aren't connected can be used, whereas it's really to try and focus down what we look at. So I suppose what has come out at the end of this is some basis for a decision support tool. And Dara are looking at this, how get an app that will have your fields, that will have your soil results, that will have your risk maps overlaying on them, that will identify areas that would be safe to spread in. These blue hash areas are where there's no runoff risk and they're low P, so you should maybe be thinking about transferring some of your slurry and manure to those areas. And then these areas which have high risk and high soil P, these are places that would be the first target for mitigation under future environmental agri-environment schemes. So it's sort of to try and put the knowledge back into farmers' hands is the ultimate objective, and then maybe further down the line to work within catchments. So a group of farmers together in a catchment might be able to agree on different levels of change that would give an overall effect on the river water quality. And that's what's sort of been discussed at the minute. So I suppose to summarise, the soil schemes have given us information that farmers can use to optimise nutrient management. Before, if you didn't know what your soil status was, you couldn't manage it. Now you can save money on buying chemical fertiliser by redistributing your organics better. Dealing with the low pH is a priority, I think, going forward, and something that will have to maybe be supported in some way. The catchment data have allowed us for the first time to get really clear relationships between farm practice generally in soil and water quality, and to think up ways of tackling that without affecting productivity. In future, DERA are talking about extending these sampling schemes across NI, although we have no idea of what form they'll take, but they do see the LiDAR risk mapping as being part of that, and there is talk on decision support development going forward. That's it anyway, as a brief overview. If any of you were in the scheme and have any specific questions, you can ask me later.